Hello, welcome to the demo of wiring software. We have discussed in the previous video that the fritzing is used for circuitry designing. We will be using wiring for a code. Wiring is also an open source software which can be downloaded from the internet. Let me just open the wiring software. As we have already discussed in our theoretical sessions that Arduino is based on C++ programming language. It is a slight variant of C++ programming languages. As you can see in the window, it already has some functions. First function is void setup, the other function is void loop. As I have already told you, Arduino has only two functions. Setup is used for setting up the initial values of the circuitry board, and loop is used for performing a set of instructions again and again. The instructions which you set on loop will be performed again and again unless the Arduino crashes or the power of the Arduino is switched off. So this is the place where you will be performing the setup codings, and this is the place where you will be performing the loop code. For compiling this code, you have to just click this button called as verify. Once you have pressed it, the code will be successfully completed if there are no errors. If there are any errors, then the compiler would bring you the errors. So you have to solve those errors and then successfully compile the program again. The errors will be displayed at the bottom section. As you can see over here, the code, there are no lines in this code. Thus, there is no errors or no instructions. So let me perform a simple code. So let me do a setup. So I would like to set the pin. So the pin number has to be noted once the designing is done to the fritzing. But now here I would like to do a demo code. So let me introduce pin mode, where pin mode is used for setting up the mode of pins. So I would like to set up the mode of pin. Suppose I have connected a red LED at the pin number 12 in Arduino. I'll be giving the pin number 12, comma, and the second parameter of pin mode function should be whether it is an input or output. Since I'm going to use LED, my LED is actually an activator, therefore the parameter would be output. It should be all in caps. As you can see as I type, the color varies. This is called as petty printers. This kind of compilers uses various colors to find the meaning of different keywords. If you have done any mistake, the color code will be different. For example, output over here is a keyword. Let me make a spelling mistake with the output. You can see the color is changed. This shows that I have done some mistake. This is an advanced compiler concept which is called as petty printers. Either I can give the number 12 over here, but it would be complex for me to use in the further codes the same number 12. So what I would do, I'll globally declare the pin number 12 for LED. So let me declare it globally. The declaration is same as the C++ syntax. So it is an int. And what name would I like to give? I can give LED, but it is recommendable to give with the color name. So it will become easy for you to use to understand which color LED is plugged in to this pin number. If I'm using red, so we can give it as red LED equals to the pin number. Since I have assigned this pin number to some variable, I can use that variable here instead of the pin number. So my variable is red underscore LED. Done. So I have done the initial setting of the LED. Likewise, many initializations are done based on the practicals which we'll be seeing in the further videos. Now loop. Here I would like to make the LED blink. So I want to perform a code where I want the LED to on and after some seconds I want it to off. So I have to write 3 lines. One is for on, the other is for waiting for some time, the other is for off. Once I write these 3 lines, it will be performed again and again. So it will be performing like on, wait, off, on, wait, off. So it gives you a blinking of an LED pattern. So let me give on. So for on, I have to provide the name of the LED, that is red LED pin number 12. Come on. I want to make the LED on, so I have to set the voltage as high. But what is this function? This is nothing but a write function, and that write function is given to an LED, where LED is a digital I/O, so I have to use digital write function. So it is digital write. Done. So you can see the color changes with the help of the petty printers. Done. Now I have made the LED to glow. Now I cannot make the LED to switch off. I cannot find the delay. I want the LED to wait for some time and then switch it off. For that I have to use the function, that is delay. Delay function takes the parameters of numbers, and that numbers is represented in the form of milliseconds. So here 3000 is nothing but milliseconds. Now the LED is on here with the help of this line. Let me give the comments for understanding. On. Here I am making the LED to wait for some time in on mode. Now I want the LED to be off. So again the same thing, digital write, LED name. For off, I have to set it to low. Now the LED is off. Again, I want a delay. So it will wait for some time and then it will again perform the looping statements. So now again I need a delay. So delay value in the form of milliseconds. I would like to give 3000 milliseconds. It is your wish to give the number of milliseconds you wanted. Now you can see I have used 3 statements. One is on, wait in on mode, off, wait in off mode. So now this Arduino will be performing only these 4 statements again and again unless the power is turned off or the Arduino is crashed. So you can see LED is on, wait in on mode, off, wait in on mode, wait in on mode, off, wait in off mode. So the Arduino will be performing in this manner. So for compiling, as I told you, I have to press this verify button. So click this verify button. You can see at the bottom it is compiling. So there is an error. What is the error? The error is the code is not according to the C++ format. We have missed it the end of the statements. So everywhere I have to give the end of the statement, that is nothing but the semicolon. So give semicolon. The syntax is same as that of the C++. And now compile again. So it is successfully compiling. We are waiting for the status. Done. Done compiling, no syntax errors found. This states that the code you have written above is successful and it is without any syntax errors. Wiring software doesn't guarantee runtime errors. It is in us. We have to check every conditions to avoid the runtime errors. Now, when you are actually performing the code on Arduino, it would be best for you to write the code in wiring and compile it and check for its successful compiling. Thus, you can avoid the unknown errors that can happen which the Arduino feels where the Arduino is unsuccessful in explaining to you the errors. But wiring allows you in understanding any errors that can occur. That's all for the today's session. This is the demo of wiring. In case if there is any doubts, we will be discussing during our practical session. Thank you.